last thing we have to do today is just kind of pull together the information that we know about the different types of lines. So majority of the lines we graph are what we would call oblique, okay? An oblique, in terms of linear equations, really means like diagonal. And these are going to be any equations that have an x and a y in them, okay? So most of the equations you graph are going to be oblique, okay? Anything that has an x and a y in the equation, anything that has an x and a y intercept is going to be an oblique line. And we write these either in slope-intercept form, which is y equals mx plus b, or in standard form, which looks like this, ax plus by equals c. Either one of these is an oblique line, okay? Now, how do you get the slope in either one of these forms? Well, in this form, it's easy, right? I'm going to grab a different color here real quick. In y equals mx plus b, your slope is just the m. So whatever number is in that first spot, that's your slope. In this form, it's a little bit trickier, or at least a little bit less obvious. It's actually going to be really easy once I show it to you. And again, mathematical purists, you're going to want to rearrange this into slope-intercept form. That's fine. Go ahead and do it, but you don't have to. I'm going to show you a shortcut. But to show you that shortcut, first I do kind of want you to go through the process with me. So I'm going to just kind of slide off here to the side, and we're going to do a couple of these together. We're going to take a few equations and rearrange them to slope-intercept forms. So if you want to write these down, you can. If not, don't worry about it. Okay, I just kind of want you to follow the steps here. So we're going to do that one. Let's do negative 10x plus 4y equals 60. And then we're just going to do this. ax plus by equals c. Okay, so super fast. I'm going to put these in slope-intercept form, and I'm trying to get you to see a pattern here. So slope-intercept form, I want y by itself. So the first thing I'm always going to do is subtract the 3x, or subtract whatever the x term is. So 5y equals, and over here on the right I'm going to write this as negative 3x plus 30. And then I'm going to divide everything by 5. So I end up with y equals negative 3/5 x plus 6. Run out of space there. Okay, there we go. Slope-intercept form. Here's my slope, right? The negative 3/5. Let's do the next one. So again, I'm going to move the x term over. This time I'm going to add the 10x. And add the 10x because it was negative to begin with. So now I have 4y equals 10x plus 60. And then I'm going to divide everything by 4. Okay? So I get y equals, now technically that's 10 over 4. I should reduce it. I'm going to keep it as a fraction, but I'm going to reduce it to 5/2 x plus 60 over 4 is 15. So here's my slope. Okay? What I want you to look at before we go on to that next one is the relationship between the numbers that you see here and the numbers that you see in your slope. Okay? Do you see that this number and this number show up over here? I just stacked them on top of one another and threw a negative in front. And the reason for that is because when I moved this 3x to the other side, I had to do the opposite of it to move it. So this 3 was positive, but I did a minus 3x to move it. Now look here. This was negative to begin with. When I moved it to the other side, it became positive. So I know my slope down here I wrote as 5/2, but look at it here. Okay? Do you see positive 10 over 4? So it's the opposite of this over this. Up here, the opposite of this over this. Let's do it with the general form. ax plus by equals c. Let's get y by itself. Okay, so if I'm solving for y, let's move the ax over. So now I have by equals negative ax plus c. Slide that up a little. And then if I'm looking to get y by itself, I'm going to divide everything by b. Okay? So final equation looks like this. Negative a over b x plus c over b. I don't really care about that c over b right now. What I really want you to see is the slope. Okay? This right here, this negative a over b, that's your magic trick for finding slope when your equation is written like this. Okay? So that's what I was getting at back here. Oh no, that stuff doesn't go away. Hang on. Okay, back to where we were. We were talking about oblique lines. When your equation is written in standard form, when it's written like this, whoops, it's written like this, you can find the slope by doing negative a over b. And again, those come from these numbers that are in front of x and y. So think about that equation that we had on the previous page. The equation we had on the previous page was 5x minus 4y equals 30. If I had asked you to find the slope of that line, okay, you would tell me that the slope was the opposite of this first number, so negative 5, over this number, which is actually negative 4. Okay, don't forget that negative goes with the 4. And then if you simplify that, it would become just 5/4. So I was able to find the slope of that line without putting it in slope-intercept form. That's a totally valid shortcut, works every single time. Okay, the other two types of lines I wanted to talk about were horizontal lines and vertical lines. And we've touched on these a little bit, but just to formalize it, make sure it's in your notes, okay? These ones do not take the same form as your oblique lines do. They don't look like these, okay? A horizontal line, hopefully you remember from our talk yesterday, is always in the form y equals some number. So, for example, if I have the equation y equals 4, that means that all the coordinates on this line are going to have a y coordinate of 4. So my x can be anything. My y has to be 4. So I can have 1, 4, 3, 4, anything I want. Okay? So now, think about what the slope of this line would look like. Well, let's use our points down here. Think about how to find slope from points. If I was going to find the slope, I would do y2 minus y1, so 4 minus 4, over x2 minus x1, so 3 minus 1. And actually, it doesn't matter what's down there on the bottom, because again, it didn't matter what I chose for my x's, because on the top, what's going to happen is 4 minus 4 is going to cancel out and make 0, and 0 over anything is just equal to 0. So these kinds of lines always have a slope of 0. And quite honestly, the faster you memorize that, the faster you can just look at a line and say, oh, it only has a y in it, the slope must be 0, the better off you're going to be. I don't want you to have to go through this process every single time. I want you to know that when you see this, the slope is equal to 0 and that it's a horizontal line. Okay, so these three pieces of information go together. Study them together. Okay, I want you to know that those three things go together. Similarly, a vertical line is going to be of the form x equals some number. Okay, so this is where my x is going to always stay the same and my y is going to change. So if I made my equation x equals 4, just to stay consistent with what I had up there, now that means that my x values have to be 4 and my y can be anything. My y could be 10. My y could be negative 50, as long as my x stays 4. Okay? So slope, just like I did before, y2 minus y1, negative 50 minus 10. And again, you're going to see that actually those two numbers don't matter to me at all, because when I do this, on the bottom this time, I'm going to get something over 0. And that is undefined. Okay? So we say that the slope of a vertical line is undefined, which is different than 0. Okay? It's important that you not confuse the two. There's a big difference. So when it's a vertical line, slope is undefined, and it's going to be x equals a number. When it's a horizontal line, it's going to be y equals a number, and the slope is going to be 0. Okay, so again, the faster you can learn the difference between these two, the better off you'll be, because you're going to get really good at working with these up here. You're going to get really good at working at these nice normal ones. It's these ones that are going to throw you for a loop. Okay, so practice those now.